Hello, Winifred Knight. My name is Mr. Ng. I am a high school AP Physics teacher and bio teacher here in SoCal, and I wanted to answer the question that you asked. So basically, you gave me this code. All right, this is the code that you gave me. And the first thing I did when I looked at this code is I looked for AUG. AUG is the start codon. AUG. This is the codon. This is the three nucleotide base that tells your cells to start making a protein. It tells the enzymes in your body to start making a protein here, right? And as I scan the code, I don't see AUG anywhere. So my assumption is that we're going to start coding from the very beginning. Like that's just the way the assignment is set up. So because I'm going to start coding from the very beginning, the first thing I got to do is I need to establish the codons. And codons are triplets of these letters. So every three of these, this is a codon. And each codon codes for an amino acid. It takes 3 letters to code for one little chunk of a protein. An amino acid is a building block for a protein. And when you have a bunch of amino acids chained together, then you might get a functional protein like, your hair, keratin, or, whatever. Right? So my first codon that I see is right here, AGU. A is my first one, G is my second, U is my third. This is the most common chart that occurs in high school. This is the chart that we used to use back when we had the old California science test. So here, the first base is A, right? A. First base is A, so I know it's going to be in this row. The second base, or the second nucleotide, the second little chunk of RNA is G. So I know it's going to be in this column, this row, and this column. So now I know it's going to be in this box. And in this box, the last letter is U. So U, so it's serine. And look, right here, serine, I already have the answer down. I didn't do the whole thing just because it wouldn't fit, right? And here, the next one, UGU. U is right here, so I know it's going to be in this column. G is right here, so I know it's going to be in this row. So now I know it's in this box, UGU. So here's U, cysteine. And here you go. Let me do one more. UAU. First letter U is right here. Second letter A is right here. So I know it's going to be in this box. And then U, right here, tyrosine. So here you go. And I did a couple of more for you just to help you out. I just couldn't finish all of them because it didn't fit very neatly. My apologies. One thing that I do want to mention, along with AUG, which is the start codon, AUG begins, there are a few that tells the cell to stop. And those include UAG, UGA, and UAA. Those are the stop codons. Good. So I'm not really sure what level of biology you're in, or if you're even in a bio class. You said biochemistry. So biochemistry could, maybe you're in a chem class, or maybe you're in an undergrad class. But I just wanted to make sure that you understood that, that these letters up here, this mRNA, is represented in diagrams here, right? And each of these little chunks, right, those represent one of these letters. AGU, right? These are the nitrogenous bases in an mRNA. And every 3 of these will code for something. So every 3 of these little chunks, these little nitrogenous bases, that's not 3, that's 2. 3 codes for one of these guys. One of those guys are amino acids. They chain together, and this thing is a polypeptide. It's like a bunch of amino acids chained together. And the stuff that the actual molecule that helps translate that is going to be this guy here, the tRNA. They carry amino acids to a site called the ribosome, where the mRNA can be read and an amino acid, a protein can be built in the order designated by the mRNA. That's an arrow, by the way. That's an arrow. Okay, hope that helps. One last little bit. Just so you know, whenever we give lessons about translation, I taught AP Bio for a while, we should probably talk about mutations. So here, this is part of the original code that you gave me. every now and then one part of the code might change. We call that a point mutation. And in this case, the point mutation is on the third letter, C, and the third letter of a codon, look, 1, 2, 3. Each of these threes are a codon. That last letter, that's like usually the safest place to get a mutation. Because sometimes you'll change that last letter and it doesn't even change the amino acid. And look here, serine, no change, because you had a point mutation, meaning you replaced that nitrogenous base from a U to a C, but no harm, no foul. Serine becomes serine, nothing happens, right? That's the most extreme case of a safe mutation. Frameshift mutations are much more dangerous. They can change a lot of code at once. Here, I inserted an extra A into your original code, and once I insert an extra A, look, AGU is serine, but UAG, that's the stop codon. And all of a sudden, when we had a beautiful protein being made, this entire protein's done, it's one amino acid, and it stops. How crazy. I hope this lesson's helped, and I thank you very much for reaching out and being curious about science.